Okay, so this time I'm going to basically just get a few more MOV forms out the way. Specifically, I'm going to focus on MOVSS, MOVSD, and then these MOVDQA, DQU, and all of the EVEX bit-specific versions. So starting with MOVSS here, this is basically just move or merge a scalar single precision floating point value. So we've got a register is 128, 128. But then for something where it's loading from memory, the memory operand is 32 bits because it's loading a scalar value. There's a couple of things to take note of in this table though. For example, this EVEX instruction here is register, register, register. This one down here is also register, register, register. This is just because they use different operand encodings where the reg and the RM fields of mod RM are just switched around. So these are basically just, one of these is like a redundant encoding that just does the same thing. So I'll just choose one of them for the encoder. There's also, for example, here we've got a register memory, and then here we've got register register, even though they're encoded in the same way. I assume that's because this one is load and this one is merge. So maybe they're split out because of this sort of description being different. For the encoder itself, though, this is basically just going to be the same as XMM2 with M32. So this would be the this would be the RM op encoding. A here is reg and then M. So I'll basically just be merging these two together for the actual encoder. Let's start by creating some tests. So we've got MOVSS. And then for this two operand form, we've got MOVSS with register, register, register memory. And then I think down here we've got potential memory with register. So we can basically just do 3 tests for this, I think. So we'll do, let's say, XMM0, XMM1. Then we'll have one which goes to memory. And then we'll have one that goes from memory, and then we'll have one that goes to memory. So I think that covers all of the legacy encoded SSE forms there. So then if we do VEX, which is VMOVSS, we've basically got 3 operands now. So I'll get to encode the, check that the VVV encoding is actually working, or implement it and make sure it's actually working. So we've got register, register, register. Then we've actually got these 2 forms as well. So this is the same as MOVSS, but I think there's no register to register form for this one when it's 2 operands. So 2 operands is always register or memory, memory or register. Then we've got register, register, register. And then let's just see what else there might be here. This is register, register, register again. So these 2 are the same, but they're just a different encoding of the same thing. So I'll just choose one of them. Maybe I'll just choose 1, 0. I suppose I'll just choose whatever NASM outputs, basically. Then we've got the memory register one here, and then it moves on to EVEX, which does basically the same sort of thing. So this has 2 operands, this one has 3 operands, and in the 2 operand case, it's only memory on one side and register on the other side, and in the 3 operand case, it's all registers, but these 2 are just the same thing as each other again. So for this then, that means I can copy these tests and put a V on the beginning. This doesn't have register to register, but it does have register memory, memory register. And then we've got one encoding which has 3 operands now, so XMM 0, 1, and 2. These are all XMM, so because they're all XMM, because they're all 128-bit wide vector instructions, we get this LIG notation here to mean that the length is ignored. And in this case, LLIG is also the same thing. It's just that the LL bits are ignored in the EVEX encoding. I think that covers the VEX ones. Then for EVEX, I think to cover this one, we'll basically just do... so again, this is a case like before where if we do XMM, 0, 1, and 2, it would be better to select the VEX encoding. So to force the selection of this EVEX encoding, I'll need to do something that requires EVEX. So I think maybe I could do like the high 16 registers, but I think maybe I'll just add these masks on. Because I've already got lots of like tests for combinations of different masks now. So I think if I just finally fix the form matching to be not so relaxed about everything, and make it stricter, then I can correctly test just using the fully decorated form of the registers here. So let's do, we'll do the same thing here, but we'll say, for example, let's say K1 with Z. And then that will force the selection of the EVEX operand, or the EVEX forms. So we've got the three register forms, and then we've got the 2 operand forms, which are register memory and then memory register. So I think I'll just take these. This one will do K1Z again, and then this one is memory, so it only takes an op mask or a write mask, whatever you want to call it, but no zeroing mask for this one. So if I just regenerate these tests and have a look at the listing to make sure it's all what I'd expect. So down here we have, this is 6.2 here, which means that we've forced EVEX for these cases. And then this one is C5, which means that we've forced VEX selection for these. And then these ones are, F3 here is like a mandatory prefix along with the map and stuff. So this one is the legacy encoding here for MOVSS. So this correctly is outputting what I'd expect, and it looks like where it can, let's see. So for this one, where it's register, 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 this has the redundant encoding as well. And in this particular case, it's choosing 1.0 as the encoding rather than 1.1. So I'll skip 1.1 and just do 1.0 as the encoding for the opcode for this form. So let's go to op mov. We'll add some more MOV ones here. So we'll say this is MOVSS. I know I'm going to do MOVSD, so I may as well add that in now. And we'll go and just add some forms quickly. So here we'll just do MOVSS, I'll do an empty table, and MOVSD. And we'll go to the encoder test. We need to add some more MOV tests here. So this one is MOVSS, and these are basically just going to be X word because they ignore the length. So first of all, we'll do this MOVSS. So we've got MOVSS with V0 and V1. So this one is V0, no memory access here, no K register, and V1. Then we've got 0 and then CX with memory. So this one is CX as a memory access. And then this one is the same, but with them swapped around, and this one is 1. Then we've got the same stuff for the VEX version. So actually, MOVSS, I need to add VMOVSS and VMOVSD. So I'll just separate these out, maybe. Yeah, okay, I'll do that. And then the forms, we'll just copy these and do V in here. Okay, so VMOVSS is the same thing, but it's VMOVSS, and we don't have the first one. So this first one now is going down here, and this is going to be a 3-operand test, so this is V2. Then we've got exactly the same one for the EVEX tests. Oh, and these need to be VMOVSS. But these ones are now going to use a K register, so this will be K1 and a zeroing mask. This one is just a K register, or an op mask. And then, yeah, and then we've got the same thing down here. So this is now K, K1, and a zeroing mask here. So let's just run these tests. Okay, could not match instruction form. So I'm actually going to update the encoder test here a little bit so I can get a bit more information finally, because I think I'm reaching that point now. So for each of these cases, when I go over a case, this is a particular listing file, so it'd be useful to see if I do run and give this the name of tg dot, I think it was listing. And then we'll do t is pointer to testing.t. And then if it runs in here, then at least I'll get the listing file name up here. Then it would be useful to not have this full panic dump coming out. So I may do... Okay, we'll do a defer in the loop, although that's not a particularly good thing to do in Go. This is just a test, so I don't really care. We'll do if r equals recover, r does not equal nil. Then we'll say, let's just copy this error. And we'll just say, for example, yeah, maybe we'll just do this to say we'll print the panic along with the assembly and the line. So we'll put the panic in there, we've got the assembly in the line. And now if it panics in the test, I'll get a bit more of a useful message. So could not match an instruction form MOVSS XMM0, XMM1 on line 183 of MOVSS EVEX listing. Okay, so that's a bit more useful for testing now. Could not match instruction form. So one of the other problems here is that I don't want to have to create lots of different variations of this, these decorators, so like different combinations of decorators. And right now I'm actually scoring and matching based on these decorators as well, which means that I can't really... It's not really that meaningful for me to just test using fully decorated operands. So I need to exclude those from the matching and make sure that my matching is actually a bit stricter now. So let's create a match for MOVSS here that would actually match anything. So let's say, for example, we've got, let's just say that there's an opcode of OX, let's just say 10 for now. And we'll try to get this matching. Okay, so this actually matched even though I don't have anything in there right now. So let's just go to the encoder and we'll have a look at the matching. So matching right now, even if nothing actually matches, this score is 0. So if we've got forms, then it will go into the loop. Score will be 0. That will be greater than high score, which right now is min int, which means that this is always true. So this always gets set to the first form that it sees no matter what, which means that we always think that we've matched a form, even though we haven't. So I think I'll just change this to 0. And we'll say, I suppose if we're if we're matching on something that doesn't have any operands, then it means that we're not going to find any overlap in the operands, which means there's going to be no score, which means that this will never trigger. So even for a valid form like syscall or ret or something, this would fail. So just the fact that something is the correct width and the operands supposedly match means that it should have at least one score. So if I just increment the score here, then I think this should fail on other tests now. Yes, so now it's failing on things like this or CPU ID. These ones don't have any operands and they're zero width. So let's just go to the forms and just make sure that they've actually got... Yeah, so these now need a width here. So if I just add a width to all these ones that are missing them, these ones should be matching on 0. We still have could not match an instruction form for no op. Okay, yeah, I need to still get these ones. So this is going to be width 0. Now no op with the sort of the 16-bit override. So I think this also needs to match on word. Then we've got CBW. Okay, this one has enc width, so we'll just do width is 0 here. And then CWD, this one down here. This one also needs 0. Okay, so now matching is a bit better. I think though that if, for example, I do width of X word in here, although so this is now matching again, because it says unsupported op-n, which is true because I haven't passed in an op-n at all for this form. That means it's actually matching this, so this is still a problem because I am passing in operands, but as far as this form knows, it doesn't have any operands. So this is more about the operands match function, I think, where right now what's happening is that if the form doesn't have an operand or any operand flags, then it just assumes that it's okay, which means that it will actually accept forms that don't have an operand, even if I've passed an operand in. So in this case, what I need to do is say that if the forms operand is basically NA, so there's nothing there, then I need to make sure that the operand that's been passed in to emit is also empty. So this would be NA. Okay, so now we don't match on this as I would expect. This one is also not matching now. So let's just go and have a look at that. So this is a ECX. So this is because it's got a width, but they need to match where the op1 is a relative displacement. Okay, so we're finally back to just this one. So I think that the form matching is now strict enough that I can move on. So we've got MOVSS. What we want to do here is match, we want to say op-n for the first thing. Op-n with the opcode 10 is going to be register, or sorry, it's going to be vec, or vec, then vec or memory. So for this would be register, then memory for the op-n. Op1 is going to be vec, and then op2 is going to be vec or memory. This one has a prefix, where the prefix is f3, and it has a map where the map is 0f. 0f is capitalized. Okay, so now it's matching that one. It's moved on to the next one that it can't match, so that's fine. Okay, so in this case, we're going to also have, this would be MR. So this one would be the potential memory one. Op2 would just be a VEC. And in this case, it's the same thing, but the opcode is 11. Now it's moving on to the vector versions here. So let's just take this because it's got the same opcodes. These still match on X word because it's ignoring the length. So these ones are going to be the same, but we don't allow two vectors. So let's just have a look at this. We got D down here, which is RM, and then we've got C, which is MR. Okay, so we'll still use RM and for this VEC and memory one, and then for the memory and VEC one, this will still be MR here. So I think that should match those. Now we get some incorrect things for these. Oh, so this is because the family is wrong now. So for these, I need family to be VEX. Oh. And now we're not matching the 3 operand form, which is fine. So now we can go and add the 3 operand form. In this case, the 3 operand form is encoding E. Oh, but they're using 1, 0, I think. So I think we need to match on this one here, which is encoding B. So this will be RVM, which I don't have as an operand encoding yet. So let's just go and add that. So this will be RVM. So VVVV is the middle one. So we'll change this operand encoding. Then we've got basically just VEC, VEC, and VEC for the operands here. This one is still F3, 0F, ignoring the W bit, and then it's a 1, 0 for the opcode. Okay, so now I just need to add that operand encoding. So we'll add that down here. This will be VM. So reg is the first operand, VVVV is the second operand, and RM is the third operand. Okay, so now we're on to the EVEX ones because they've got these op masks on them. So in this case, I basically just want the same thing. Let's see, this one's not matching form. We'll just do the same thing. Maybe we'll just copy all of these. These ones are EVEX. But the difference is that this memory one, for example, can have an op mask. And then these two here can have an op mask. And they can have zeroing. Okay, that passes. So that happened to be the correct opcodes as well. Okay, so that's MOVSS done. MOVSD is going to be basically the same thing, but this time the prefix is F2 instead of F3 by the looks of it. They all ignore the length again because they're all X words, so that's fine. So I think we can just, well, let's just do the tests first. So we'll take all of these MOVSS ones and change them to MOVSD. Let's regenerate the listing, encoder test. We'll just copy all of these SS ones again. These become SD. So let's do the tests. Okay, unsupported op-n for MOVSD. That's because I haven't filled anything in yet. This is saying unsupported. So MOVSD still thinks that it's matching something then. So we've got MOVSD here with nothing in it. So let's just go to the encoder. So we go score. This is not falling in. So I need to change this, yeah. So I need to make sure that this is actually going to be a 0. Okay, so now it can't match a form, which is correct. So we'll just copy these MOVSS ones in. And we'll copy these MOVSD ones. So now it's incorrect because the prefix is incorrect. So the prefix for these ones is going to be F2, and the same with MOVSD here. Okay, so now we're getting slightly incorrect bits over there for the EVEX ones. So let's check EVEX. This could, okay, I think this is because this one is a W1 here. So on the EVEX versions for MOVSD, I need to say that W is W1. Okay. So now let's move on to MOVDQA. So there are obviously quite a lot of forms here. They're all 2 operand. So let's just see if I can maybe copy these ones out. Or let's see, yeah, I'll copy these out so I can see them a bit better. Okay, let's just take all of these, put them into Sublime. Okay, so I guess if I just do selection on here and go maybe down at least 1. Okay, let's just take all of those. Okay, I think this should be all of the forms. So we've got 32 and 64 here. This only has 32 and 64, so that's fine. Then we've got MOVDQA, which doesn't have the bit-specific stuff on here. So now let's just go and get rid of these descriptions. So we've got this one. Okay, so it looks like these are all of the forms. So we've got MOVDQA with, it looks like 2 of the, yeah, so it's just the flipped around here, so that's fine. Then we've got VMOVDQA, which is just the same thing but with YMM, so this has the length in it. And then we've got a split between 32 and 64 here. So these are the EVEX ones that go with XMM, YMM, and ZMM. So let's just take all of these into the tests. So this is MOVSS ASM tests. All right, let's just put all of these here. So for this one, we'll do, I guess we'll just keep these as they are. But this one can be RCX, for example, to cover the memory one. And then we just need one more memory one here. So this is also RCX. Then it looks like we've got the same thing, but these ones are V. And we'll copy these again so that we can add a YMM. And then we've got the same stuff again, but we also need ZMM. And in these cases, I can also do a test using K-masks. So these ones are Z here. This one is just K1 because it's memory. Okay, let's just go to the comma and put those in, comma, put those in. So I think that covers all of these. We've got register and then register memory for ZMM, I think. Yep, so there's a register, register, register memory, memory register. That should cover all of these forms. So these ones are VMOVDQA 32. And then I need to just do the same thing, but with 64. By the looks of it. So let's just see if NASM is okay with that. Yep, seems okay. And I'll just have a look at the listing again, just to make sure that, yeah, so I mean, I guess these ones are EVEX anyway because of the instruction. I don't necessarily need these to force EVEX in this case, but, you know, just for the sake of having a full decorator test, I guess, I'll leave it on there. So now to start implementing these things. So we've got all of the tests here. I think I'll just take all of these and take them to Encoder test. So we'll just comment all of these and do an copy and paste those in. Uppercase, we'll do op something. Let's just go to op MOVSS, for example, and I'll just paste these all in here. Deduplicate. Go to forms, chuck them in here. These can all just be empty tables for now. So all of these are going to match on different widths now. We've got V1 and V2 at least, and then these are NA, NA, because they're all 2 operand. So this one is now cx.m. This one is also cx.m, and this one is V1. Then this one, these are all X-word. So let's just copy these down into here. These ones are VMOV. And then we've got the same thing again, but this one is going to be Y-word. Then it looks like we've basically got the same thing again. I'll just copy these ones first. So these ones will be VMOVDQA 32. These ones are X-word. We've got V1 and V1 here are doing K1 with zeroing mask, and then this memory one is just doing K with K1. Then we've got the same thing down here again. This one is Y-word. And then the same thing down here again, but this one is Z-word. Then all of these can be copied down here, but then we just change this to 64. Okay, so let's just get rid of these comments as well. And go fill in some forms. So the forms for MOVDQA, I'll just copy some of these forms to get started. So MOVDQA in here is, it's got a prefix of 66. Map is the secondary opcode map. So this prefix here is 66. The map is the secondary one, and then the opcode itself is 6F. And this is matching on, so this is A, this is going to be RM, which is correct for this one. This is vec, vec-mem, xword, that is fine. Then this second one here is just flipping the operand encoding around. So this one is mr with vec-mem and then just vec. And this one's opcode is 7f. Then we've got, looks like we go straight into the VEX ones now. So this will be family is VEX. So we'll keep xword here. Again, we've got, I think it's all the same stuff, but the difference is that these will match also on yword. And the opcode is the same. The length is not ignored, so that's fine. Prefix is the same, opcode map is the same, W is ignored. That all seems okay. Actually, these ones are the V version, aren't they? So these ones should move down to this one. Then we've got the EVEX version, so 32. Let's just copy these VEX ones here. These ones are the EVEX. These ones need family as well, before I forget about it. So this is VEX. This one is family EVEX. And then we've got, I guess it's basically the same stuff, but this time we're allowing, in VEC, we're allowing op mask and zeroing. And then in here we're also allowing op mask and zeroing, I think. And then the other difference here is that this is also going to match on Z word. So the opcode for these ones is still the same, 6F and then 7F. The W bit is set for the 64-bit version. So let's just go and put these in 64, and these need W to be W1. Okay, that all passes. Okay. There is something that I just realized that I missed as well, though, that in the encoder, I said that I didn't want to score on decorators. So let's just go to these. And actually, while I'm here, okay, let's just clean this up a bit. So down here, we'll have decorators and validation flags. So decorators are going to be things like op mask and zeroing, and a bit later this will also include rounding and broadcast as well. Kreg I'll actually move up here so that it's with the other register stuff. So what we want is that this will be, for example, operand decorators. Decorators is equal to op mask or zeroing or requires EVEX. And then operand kinds will be equal to the inverse of the operand decorators. Then I can use this in the scoring to mask off only the bits that should actually be used for the scoring. So let's just make sure this still works. Yep. That way my tests where I'm just doing like a full decorated operand only are a bit more meaningful, because I know that they'll just be matching on stuff that's not decorators, but the decorators are still being sort of validated in the operands match function. So anyway, that was a VMOVDQA. I assume that this one is going to be more of the same, but the prefix is different. And there are more versions of this. So this one actually has DQU 8 and 16 by the looks of it as well. So let's just copy all of these ones. So instead of DQA, these are now DQU. And we've got two extra versions of this, which are DQ 8 and 16. So we'll go to MOVDQA. We'll just copy all of these. These are now DQU, and we've got two more versions, 8 and 16. So for the test for this, we'll do MOVSSE. We'll just take all of these ones, change them all to DQU, and then I'll just take a copy of these and change them to 8 and 16. Let's just see if NASM's okay with that. Seems okay. I assume that that's the I assume that's the difference without actually reading this table properly. You know, this is a DQ8. It still has there's still only 2 operands. They're still in the same sort of encoding and everything. So I think that should be okay. So let's just do, I need to add the tests. So encoder test. Let's just copy all of these ones. And then we'll change to DQU. And then we'll just update this so that we add 2 more blocks. All of these become 8, and then all of these ones down here become 16. Okay, so they all match forms. They just have the incorrect encoding now, which is expected. So these all have the prefix of F3. So we'll just change the prefix for that to F3 for all of these, so that it's no longer 66. These all change to F3. Then what else is different about these? It looks like maybe the W bit is set on some of them. So 64 still has the W bit set, and 16 also has the W bit set. So let's just go to 16 over here. These ones need the W bit set to W1. 64 already has it. So this is still all just DQU 16 and 8 that are not matching correctly. So these have the correct opcode by the looks of it. But one of the prefix bits is incorrect. So what is different here? This is F2. And then I assume that means that 8 is also F2. Yeah, F2, and then 16 down here is also F2. So let's change the prefix for 8 and 16 to F2. Okay, so that was making the form matching a bit stricter, a bit more accurate, and then I've now got a decent batch of like MOV instructions for SSE, AVX, AVX 512. Some of these also, so we're going to get to the tuple types and things soon. These ones have a full mem here, but I think that MOVSS, for example, has tuple1 scalar. So they give me a couple of different tuple types to use later with the compressed DISP8 encoding that EVEX has.